Something unbelievable has just reached us from the depths of our solar system. Images so detailed, so hauntingly beautiful, that scientists at NASA were left speechless. The Europa Clipper has finally sent back its first close-up visuals of Europa, Jupiter's icy moon. And what we're seeing is unlike anything ever captured before. Cracks that stretch for miles across a frozen shell, mysterious ridges that pulse with a strange glow, and strange dark streaks that seem to hint at something stirring beneath the surface. What exactly are we looking at? Is this just geology, or something far more profound? For decades, Europa has been one of the most promising places in the solar system to search for life. Beneath its icy crust lies a vast ocean, more water than all of Earth's oceans combined. But until now, we've only had distant glimpses, blurry images that left more questions than answers. Now, with the Europa Clipper in orbit and its instruments humming with data, everything is changing. In this video, we'll explore what these shocking new images reveal, why scientists believe Europa's ocean could be habitable, and how the strange surface markings might be connected to alien life. We'll also uncover the astonishing engineering behind the spacecraft that made this mission possible. And what's next for our search beyond Earth? Europa has long been a source of fascination, not just for scientists, but for anyone who's ever looked up at Jupiter through a telescope and wondered what lies beyond. Roughly the size of Earth's moon, Europa orbits the gas giant every 3.5 days, locked in a gravitational dance that constantly stretches and squeezes its icy shell. This intense tidal flexing generates internal heat, which in turn is believed to keep a massive subsurface ocean in a liquid state. That ocean, buried beneath an estimated 15 to 25 kilometers of ice, could be the most promising place in the solar system to find alien life. Discovered in 1610 by Galileo Galilei, Europa has always stood apart from Jupiter's other moons. It lacks towering volcanoes like Io, or the chaotic terrain of Ganymede. Instead, Europa's surface is eerily smooth and pale, crisscrossed by long, reddish fractures that look like veins frozen in time. For decades, these mysterious lines baffled astronomers. What causes them? What lies beneath them? Then, in the late 1990s, the Galileo spacecraft flew past Europa and captured tantalizing images of a fractured ice world, a place that might be hiding something beneath the surface. Since then, the mystery has only deepened. Plumes of water, vapor have been detected shooting into space. Magnetic field readings hinted at something conductive, perhaps salty water, beneath the ice. But, until now, no mission has ever been able to get close enough for long enough to give us the full picture. That's where the Europa Clipper comes in, and it's rewriting everything we thought we knew. What the Europa Clipper is uncovering isn't just stunning, it's scientifically groundbreaking. At its core, the mission is about understanding whether this icy moon has the right conditions to support life. And to do that, we have to look beneath the surface. Europa's icy shell, though cold and forbidding, acts like a protective blanket, insulating what scientists now believe is a vast global ocean. And it's not just the existence of that ocean that excites researchers. It's what's happening inside it. Using instruments like the Europa Thermal Emission Imaging System and the radar for Europa assessment and sounding, ocean to near surface, the Clipper is mapping the moon's surface in unprecedented detail and peering deep into the ice. It's detecting variations in temperature that suggest there are warmer regions beneath the crust, possible signs of hydrothermal vents, just like the ones at the bottom of Earth's oceans. On Earth, these vents teem with life, even in total darkness, feeding off minerals and heat rather than sunlight. If similar vents exist on Europa, we could be looking at the same kind of ecosystem, alien, self-contained, and thriving in complete isolation. Then there are the surface features themselves. The dark lines and ridges seen in the latest images show signs of movement, where ice plates appear to have shifted, broken, and refrozen, much like tectonic activity on Earth. This dynamic behavior means the ocean and the surface might be interacting, allowing chemicals and energy to mix. That's key, because life, as we know it, needs not just water, but energy and complex molecules to get started. Add to this the Hubble Space Telescope's earlier discovery of water vapor plumes erupting from Europa's surface, and the ice pieces begin to connect. If those plumes are linked to subsurface lakes or ocean vents, they could be carrying organic molecules to the surface. The Clipper is equipped to analyze this material, hunting for signs of carbon-based chemistry, the kind that could point directly to biological processes. All of this raises a thrilling, almost overwhelming question. Are we standing on the edge of discovering alien life just a few 100 million miles away, under the ice of Jupiter's mysterious moon? While Europa itself isn't about to explode or erupt like a star, the events unfolding beneath its icy shell are happening on a timeline that challenges our human sense of time and patience. The signs we're seeing now, the shifting ice, the possible plume activity, could be part of a process that has been going on for thousands or even millions of years, but some changes might be happening right now, beneath the surface, hidden from our eyes. Because Europa orbits relatively close to us, about 390 million miles away, what we see with our spacecraft is almost real-time, though light still takes about 35 minutes to travel from there to Earth. That means the images and data the Clipper is sending back reveal events happening just a short time ago in cosmic terms. If there's any sudden burst of activity, a powerful plume eruption, or a dramatic shift in the ice, we could witness it within our lifetime. Imagine a plume so large and bright that it reflects sunlight like a beacon in the dark, perhaps even shining as brightly as the full moon. Such a sight would be visible not only through telescopes, but maybe even from Earth's night sky with the naked eye. While Europa's changes won't produce the fireworks of a supernova or a comet's tail streaking across the sky, the slow, eerie dance of ice and water beneath its surface could offer a spectacle unlike any other. A hidden ocean world whispering secrets of life beyond Earth. Right in our cosmic backyard, Europa won't explode like a star, but imagine for a moment if beneath its icy crust a colossal plume suddenly bursts forth, sending a towering column of water vapor and ice particles shooting into space, a cosmic geyser lighting up the darkness. Picture stepping outside on a clear night and seeing a shimmering, glowing plume stretching thousands of miles above Jupiter's giant shadow, glowing softly with the reflected light of the distant sun. It would be a celestial spectacle unlike anything humanity has ever witnessed. The brightness could rival the brightest planets in our sky, glowing with a ghostly blue-white hue, visible even to the naked eye from Earth's surface. For days, or even weeks, this mysterious beacon would dominate the night sky, a silent announcement that life's possibilities extend far beyond our world. Across continents, people would lift their gaze upward, united in awe and wonder, witnessing a silent cosmic event that connects us all. For scientists, this moment would be historic, a living laboratory offering direct clues about life beyond Earth. For humanity as a whole, it would be a profound awakening, a reminder of how small and connected we are in the vastness of space. This wouldn't just be an astronomical event. It would be a once-in-a-civilization moment, a spark of hope and curiosity lighting the way for generations to come. The sky would become our storyteller, revealing secrets hidden for eons beneath Europa's frozen surface. While Europa's icy plumes might not forge heavy elements like gold or uranium the way massive stars do in their fiery deaths, the moon's activity still holds incredible scientific value, a gold mine for understanding the conditions that make life possible beyond Earth. Think of Europa as a unique laboratory where water, chemistry, and energy collide beneath a frozen shell, creating an environment that could support life in ways we've never seen before. In the grand cosmic cycle, stars like Antares or VY Canis Majoris live fast and die spectacularly, exploding as supernovae that scatter precious elements, gold, platinum, uranium, across the universe. Those elements eventually become part of planets, moons, and even living beings. Every atom in our bodies was forged in the heart of ancient stars, connecting us deeply to the cosmos. Europa represents the next chapter in this cosmic story. Its ocean, heated by tidal forces and possibly enriched by chemicals from the moon's rocky interior, could be a cradle for life's building blocks. Studying Europa's plumes and surface, activity gives us a glimpse into how life might arise in places vastly different from our own planet, worlds shaped not by sunlight, but by hidden heat and chemistry. This exploration ties us to the larger universe, reminding us that life's ingredients are everywhere, cycling through stars, planets, and moons. Europa is more than just a distant moon. It's a symbol of hope and discovery, showing us that the story of life is a cosmic one, written across time and space, waiting for us to read its next chapter. Although the discoveries from Europa are awe-inspiring, it's important to reassure everyone that Earth faces no danger from these events. Europa's activity, while dramatic on a cosmic scale, poses no threat to our planet. Unlike supernovae, which can release harmful radiation across vast distances, Europa's plumes and shifting ice are safely contained within our solar system, far from Earth's environment. That said, if we were observing a more powerful cosmic event nearby, like a supernova, we might notice harmless atmospheric effects, such as vibrant auroras dancing across the poles or slight increases in ionization in the upper atmosphere. These phenomena are beautiful reminders of our connection to the universe and do not pose any real risk. Scientists around the world use highly sensitive neutrino detectors and gravitational wave observatories to monitor space for warning signs before light or harmful particles reach us. This global network acts like an early alert system, giving astronomers time to prepare and inform the public. So, while the cosmos may be full of spectacular and sometimes violent events, our planet is well protected, allowing us to watch and wonder safely from here on Earth. As we stand beneath the vast expanse of the night sky, it's humbling to realize that we are witnessing moments shaped by forces far beyond our everyday experience. Europa's restless ice and mysterious plumes are like whispers from a hidden world, echoes of ancient processes unfolding in slow motion. They remind us that even in the cold silence of space, life's potential stirs quietly, waiting to be discovered. In a universe measured in billions of years and unimaginable distances, these fleeting glimpses connect us to something far greater than ourselves, a cosmic story that has been unfolding since the dawn of time. We are, in a very real sense, part of this grand tapestry, bound by the same atoms forged in stars and carried across space to create worlds like Europa and life like ours. So, as we close this chapter of discovery, let's keep our eyes on the skies and our minds open to the wonders still hidden among the stars. The universe is a vast, mysterious place, full of secrets waiting patiently for us to uncover. Every new mission, every new image, every new discovery brings us one step closer to understanding our place in the cosmos. And that is a journey worth taking together. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. Your curiosity fuels our journey through the cosmos. Thank you for being